This is Mike Kruse with AC-Tek, and in this video I'm going to show you how to import your chute geometry into Newton, and I'm going to explain which CAD file types are supported. So if you go to the Import Geometry window and click the Import CAD button, you can select a file to import. Newton supports the IGES, STEP, Dxf, and Stl file types. So with the IGES file type we support version 5.3. With the STEP file type we support AP203 and AP214. With Dxf files, you have to draw your surfaces using only 3D faces, or you have to convert all your surfaces to 3D faces. And with STL, an STL file just writes everything out in triangles, so we support any STL file. So if we go ahead and import an IGES file, we can take a look at this import window. So once you select the file, Newton's going to load that file and create a preview in the rendering window, and it's going to pop open this other window at the same time. And this other window is going to list all the layers that it found in the bottom half. And the top half contains some global parameters for the entire model. So this position offset XYZ, is really only used for STL file types. So if you had an STL file type that was in several different files, you might need to reposition each specific file. You might need to relative to the origin when you're importing. But generally with Dxf or IGES or STEP files, you're not even going to use that. The scaling factor is for if you need to change the dimensions. Generally with IGES files and STEP files, Newton can probably find the dimensions inside the file type and it can adjust accordingly, but you might need to specify the scaling factor otherwise. So for example, if my drawing was in inches, I might need to punch in 25.4. The positive vertical axis is simply which direction is up, because some programs like SolidWorks use the positive Y direction as up, but Newton uses the positive Z direction. So if you're working in SolidWorks, you can just set that at +Y and import your geometry. Recalculate normal vectors will recalculate all those normals for each specific triangle in the model. Generally with IGES and STEP files, you don't need to recalculate those vectors because they're almost always correct. But with Dxf and STL files, you probably want to recalculate. So when I select a Dxf or an STL file from that dialog, it's going to automatically check this box for me, but you can uncheck it if you want. The minimum triangle area will simply ignore all triangles that have areas smaller than this value. So if I set this at, say 10,000 or 1/10 of a square meter, we're going to be missing a lot of those little triangles. So that's useful if you have a bunch of tiny triangles that you want to ignore. Obviously, we don't want to ignore all these little triangles though. And then finally, we have the IGES mesh resolution. This mesh resolution is for STEP or IGES, and basically it controls the triangulation of your circles and arcs and cylinders. So basically, when we look at this, we're going to want, because we have this continuously curved hood and continuous spoon, we're probably going to want ultra quality for those two pieces. But everything else, with the exception of the head pulley, everything else, it doesn't really matter what the quality is set at because the triangle count is not going to change much, because the rest of these components don't even have circles in them. So we'll go ahead and do that. And I suppose before we import, we should explain some of these parameters down here. So all the way on the left, we have a checkbox which indicates whether we want to import each layer. So if I uncheck something, now we're not going to see it in the preview window because we're not importing it. You can check or uncheck all of them right here. The next column is the layer name from the file. So this was actually the layer name that's embedded in your STEP or IGES or Dxf file. Add to layer is specifying which layer do I want to put it on. So if I wanted, I could put all of these on the same layer. And then if I wanted, I could also rename that layer and call it test. And then these overwrite checkboxes specify, do I want to overwrite an existing layer? So if test was a layer that already existed here, then this checkbox, if it was checked, I'm going to delete that existing layer and replace it with all of these triangles instead. If I uncheck this, then we're just going to add all these layers to that same layer and keep those existing triangles. And the number of triangles, that lists the number of triangles in each layer and the total number of triangles in this file that you're importing. So we can go ahead and click import, but everything's on the same layer, so we're going to want to re-import that. We'll just say new file. and import. Okay. So the only reason we imported this head pulley and this feed belt is so that we can use it to position an automatic feed belt in Newton. Because generally, whenever you draw a feed belt in Newton, it's going to have much better resolution around the head pulley and in the transition section than any belt that you import. Because I mean, if you look at this, even though we had it on ultra quality, this transition section still doesn't look right anyway. So for this transfer chute, I believe is the belt with 1200. Yes. So once you punch in that 1200, it's going to automatically generate a belt with a few default parameters here. And all of these parameters here are covered in a separate tutorial. The purpose of this video is just to show you that you can quickly set up a belt to replace an existing belt in a layer. So I'm not going to go through all of these inputs. So once we set that belt width, we want to specify a few other parameters. We want to set the head pulley diameter. So this number here should include the diameter of the head pulley plus the lagging thickness plus the belt thickness, because we want it to extend all the way to whatever surface those particles are moving along, which is all the way up to the top face of the belt. So for this, I believe that value is 650. Yes. And then next, we want to make sure that our transition length is proper, and we can see that the transition length is matched right there, so we don't need to change it. I think that's 2.4, yep. And then the head pulley elevation is the other parameter we can't forget about, because that controls the inclination right here. So is that 100 millimeters, 110, 135. Okay, so now if I switch back to a solid view, you can see that we've basically lined our belt up perfectly on top of that existing belt. So now we can go ahead and delete that existing feed belt, and we can delete that head pulley. We don't want that head pulley either. And lastly, we probably want to specify a speed for that belt, 3 meters per second. And we can check that by turning on our velocity vectors. We can see that all those vectors in the transition section are properly pointing along the transition. Same with the head pulley. Okay, now next we'll go ahead and do the same thing with our receiving belt. So that receiving belt is also a 3-roll belt, and it's the same 1200 millimeter width. So if I switch to a top view, I can quickly position this. Let's turn that off. So we got a rotation angle of 90 degrees, and we don't want a transition or a head pulley, so we'll just go ahead and delete that. We'll turn off our drop box, and we'll set the length of our trough section of the belt at 6 meters. And now I want to take and line this up directly over this other one. So what you want to do is basically in your CAD file, you want to take a measurement from the origin of your CAD model to this front top center of the belt right there. And you want to take that measurement and you're going to punch that in the XYZ offset here. And so for this, those numbers are... What are those numbers? Negative 4.75. and 1.315, and negative 1.967. So now if I switch to my front view, we've almost lined it up perfectly. However, we can see that the center width is slightly different. Newton is overestimating the center width of the belt. So in reality, I think this was drawn with a perfect 33, 33, 33. Oops, not 4400. There we go. So now we can go ahead and delete that existing receiving belt as well. And the last thing we're going to want to do is not forget to set a speed on that receiving belt. So basically, we were able to quickly import our chute geometry and set up a feed belt and a receiving belt in Newton. And one of the other reasons you're going to want to use these belts in Newton is because if you're trying to do something like analyze, record the triangle forces or triangle wear, it's so much easier to mesh up a belt in Newton, because you can just go down to this max triangle size and say 100. And that's going to mesh up these triangles so that the average side length is 100 millimeters, or 80, or 70, or 50. And it's much easier than trying to mesh up the belt by yourself in your CAD program. So now if I wanted to, let's say I wanted to overwrite this existing hood. Let's say I didn't like the design of the hood and I wanted to put a new one in there. Well, I can just go back to my import CAD. I can say I have my alternative hood right here. And you can see there's that alternative hood right there. Now, clearly this doesn't properly fit in this head chute, but we just picked it as an example here. So let's change it a little bit so that it does. There you go, close enough. So again, with this hood, I want to put that on the hood layer, and by default, it's going to overwrite that layer. So you can see that the existing hood disappeared. But if I didn't want to, I could uncheck that. So let's just move this to the side for a second. So back to, we were talking earlier about the layer colors, surfaces. We were talking earlier about the layer colors. So the existing geometry is rendered as gray. So just like all the surfaces in the new CAD file are blue, the existing geometry in the model is gray. The current selected layer in the new file is going to be magenta, and if that's set to override or add to an existing layer, then that existing layer is going to be shown as green. So once I check the overwrite box, that layer disappears, because it's showing you a preview of what the geometry is going to look like. That hood is going to go away, and this one's going to take its place. If I uncheck my import button, then this one comes back, because even though I told this to overwrite, I'm not actually importing this hood, so it doesn't matter. So I can still see that existing hood. So we want to overwrite that and get rid of our offset here, and click import. Oh, and of course we want the ultra resolution as well, because this is also a smooth hood. And that's how easy it is to swap out a hood with a new hood. So let's take a quick peek at importing a step file. So if I switch to a different chute and open up a step file, basically the process is going to be exactly the same. We don't want any of these offset or scaling factors, but it's going to look through the file and it's going to look for different parts and different solids, and exactly how many parts and solids it finds, it totally depends on the way you define it in SolidWorks or Inventor. But generally the best way to draw these models is to have an assembly where each specific piece of the chute is on a different layer, is a different part rather. So you want this belt to be a different part, the head pulley to be a different part, the chute, the lower chute, the skirt, and the receiving belt, because then it's guaranteed that it's going to find each of those separate layers. You don't want to define everything as one single part. You want each of these to be a separate part in an assembly, and then export that assembly to a step file or an IGES file. And basically the import process is exactly the same. Nothing changes. We can go ahead and import all of our chute pieces, and if we wanted, we could go ahead and set up a feed belt and a receiving belt to take the place of those belts, and then we would just go ahead and delete those from the geometry. So what if instead we wanted to open up a Dxf file? Well, the import process is again exactly the same. It's going to scan that Dxf file and it's going to find all the layers that have at least one 3D face on it. It's going to find all of those layers, including hidden layers, including frozen layers. And you go through and say, well, do I not want to include any of these? Maybe I don't care about this scrap metal chute, so I'm just going to go ahead and delete that. And it put all of those on a separate layer. And it kept those are the actual layer names from the file. It found those layer names and imported them. So if I wanted to import that again, let's say we want to offset it again. If I uncheck all of my overwrite, get rid of that scrap metal chute, you can see the existing layer is green, the new layer is magenta. So maybe we want to overwrite chute 1, but for some reason we want to keep all the rest of this stuff. So I can just overwrite just that one, and I can skip my scrap metal chute again because we don't want it. Click import, and there's our model. Finally, if we wanted to open up a STL file, as I said earlier, with STL files, they don't support different layers. So each STL file is just one single layer. So if you want to use STL file type, what you're going to do is take each specific piece of the chute and export it to a separate STL file, and then you're going to import these into Newton one at a time. So we import our chute, and again we might want to set the position offset, because for this particular model all of the individual STL files are all referenced to the same origin right here. But sometimes if you export STL files, it might place the origin about the center of gravity of the part. And in that case, you need to be able to specify your XYZ offset for each specific part. For this, we don't need to. So I'll go ahead and import the chute, import the discharge, import the receiving belt, and import the skirt. And if I wanted to go ahead and set up a feed belt, I could go ahead and do that right there and specify all my parameters. And of course I could go and replace this with an existing feed belt, with a auto-generated feed receiving belt if I wanted to. So one of the advantages of STL files is that it's basically supported by every CAD type, because STL files, the STL type is what you use for 3D printers, so pretty much every CAD program is going to support it. So it's kind of like a last resort. If you can't export to IGES or step files, you can always use the STL file type. So I think that pretty much covers everything we wanted to discuss regarding the import of the different file types. So if you have any questions, please feel free to send us an email at info@actech.com. Thanks.